All right, so I think we're gonna get started. I gave them 10 minutes, is that okay? Okay, cool. If anyone joins us, we'll just kind of keep rolling from there. But today we are gonna talk about freshwater. Let me just pull up my screen, make sure my PowerPoint is good to go. All right, boom. Let's see. Nice. All right, awesome. All right, so we're talking about freshwater today. So there are a couple things that all living things need on Earth to survive. So if you want to go ahead and type some of the answers that you think in the chat, go for it. So what does every creature on Earth need? Question, how do I pull up the chat? Oh, there we go. I went full screen and now I can't find it. Let me see. And I went there and then I clicked. Oh, awesome. There it is. How did you do that? I don't know. Magic. It's okay. Don't worry. All right. So all living things on Earth need a couple things to survive. The most important one is going to be water. PowerPoint, you working today? There we go. So all living things need water, they need shelter, they need food, and they need space to survive. Sometimes, I also kind of include air in that, but it gets a little confusing, especially when we're talking about marine creatures, because then kids will debate with me, oh, but fish don't breathe air, which I'm like, yes, you are correct, because technically they take the oxygen out of the water. So just to keep it general, they all need water, shelter, food, and space to survive. So here are some examples of what those would include. Humans, we fall into that category as well. So do you know, how is freshwater important to us as humans? You want to type that in the chat. I lost the chat again. Why is this happening? Please help. I've come undone. Oh, you stopped the sharing. Yeah, I think that you were sharing weirdly. I did the share. Okay.
I think last time I had that problem, just keep clicking Alt-H anytime you want to see it.
Okay, cool. So we use water every single day, whether we realize it or not. And the main things that we know we're using water when we drink it, when we shower, when we brush our teeth. But everything that we eat required water at some point. Everything we wear definitely required water at some point. So water is a big component of humans and just like what we need to survive. Oh, man, technical difficulties today. Just pop a squat over here. Oh, there we go. So like I said, everything we do requires water at some point. Our bodies are made up of about 65% water, kind of depends. So it varies how old you are, your gender, and just the body fat that you have as well. It also depends on how hydrated you are. So for those humans who drink a lot of water like me, I'd probably be a little bit more hydrated than someone like my mom who forgets to drink water, even with a cup on her desk all the time. And then it kind of breaks down, if you look at the photo on the left, just the different organs of your body, which ones have the most water in them. I was surprised with the eyes. I thought for sure our brain would have more water than our eyes. So I was very surprised by that. And of course, our blood has a lot of water in it as well. And we are constantly losing water, breathing, sweating, going to the bathroom, things like that. So we do have to make sure that we are staying hydrated because there are some effects on our bodies. I know if I don't drink water, if I have a headache, first thing I do, I'm like, when's the last time I drank water? Because that's usually the first sign for my body to be like, hey, I'm thirsty, please drink. We can also get a lot of our food or water from food that we eat. Especially with our fruits and vegetables, like celery, that's basically water in a crunchy vegetable. Zucchini, cucumbers, things like that. Watermelon is mostly water. They named that one correctly. A lot of the melons as well. So We don't always, like, you don't have to get all of your water from actually drinking a liquid, but you should. But you do get a good amount depending on what your diet is, if you eat a lot of fresh fruits and vegetables. So water on Earth, if we look at this planet, or if we look at the picture of Earth, so looking at it, it's mostly blue. So I think they named the planet wrong. I think it should be called oceans, because about 70% of all of Earth is covered in water. And if we were to break down that 70%, 97% of it would be salt water, so all of our oceans, and only 3% of that would be freshwater. The figure on the bottom left breaks it down even more. So we'll just kind of talk about the freshwater. So of that 3% of freshwater, about 1% is really accessible for all 7.8+ billion humans on this planet, as well as all of our terrestrial animals and our terrestrial plants and things like that. So it's not a lot of fresh water available if you think about it. Most of it is stored either underground or in our ice caps, so we just can't access it. A lot of times, this sometimes gets confusing, but technically water is a renewable resource if we manage it properly. So the way it's renewable naturally is through the water cycle, but because we need water and just how society has kind of progressed, that we have sewage treatment plants and things like that, we have to make sure that we're being mindful of our water usage, because it could become a non-renewable resource if we aren't taking care of it, if we're not being mindful and being responsible of it. But technically it is a renewable resource through the water cycle, but because of how humans have manipulated the water cycle to benefit us, we just have to make sure that we're being careful on what we use it in. So like I said, the water cycle is huge. That is where most of our fresh water comes from. And this diagram just gives a really good, brief but in-depth look of what it is. So when we're growing up, we know condensation, evaporation, precipitation. Those are like the 3 major things, along with runoff. But as you get older, you get a few more terms in there. It gets a little bit more complicated. So I'm just going to add 2 more terms, not too crazy, but we'll add transpiration and we will add respiration, and I'll kind of touch on those more. So water is always on the move. Even if you can't see it, it's always moving, whether it's evaporating, whether it's condensing. Right now, there's a lot of condensation happening up in the clouds. And like I told you, the weather, we're supposed to get some rain, so the precipitation will be happening soon. And it's always changing between its 3 forms, so gas, solid, or liquid. So it could be water, it could be ice, or it could be water vapor. I'm going to pull up this video just to give you a brief synopsis of the water cycle.
You may think every drop of rain falling from the sky or each drop of you, but it has always been here and is a part of the water cycle. And let's face it, water continuously moves from the ground to the atmosphere. It just works. Water is the only substance that naturally exists in 3 states on Earth: solid, liquid, and gas. Over 96% of total global wealth is in the ocean. So what's our plan? Energy from the sun causes water on the surface to evaporate.
Internet. Oh. Technical difficulties.
Instead of snow melting and running off into the river, it can become a glacier and stay there.
Internet, you're letting me down today.
Gas directly through the leaves and it turns to gas. All 7 feet through the outline. Groundwater can work its way out to a lake, river, or even the ocean.
I'm doing great. The internet's not doing so.
A very complicated process, and all its paths through Earth's ecosystems are water is essential to life on Earth. Freshwater is a limited.
Come on, I need like 15 more seconds, and then I can cut it off.
Recreation, transportation, agriculture, and drinking water. And that's my understanding of the water cycle.
All right, I think we're gonna end it there because this video is saying that it's done, so we're just gonna keep rolling. And so it's a really good demonstration, and I like especially working with kids, it just shows them how one water droplet could start as a rain droplet, but the path that it takes, it could take maybe a couple minutes from evaporating from the sun to get back up to the clouds, or it could go on a journey, go underneath the ground, go into a river, go into a lake, and then eventually go to the ocean. So water, it can take either a little bit or a long bit of time to kind of keep continuing in the cycle. So the USGS has a fantastic website, especially working with kids. It's really great. It goes into depth, and they have this game where you can actually be a water droplet, and then you get to go on this journey and this adventure. It prompts you, so it asks questions as you go along. So it'll be like, okay, I just fell down from the sky. What is that called? And then you have to click on precipitation, and you get to, if you follow from the clouds, here, it runs off, then we talk about what runoff is, then it goes to our rivers, and it just shows the interconnectedness of all water on Earth. A lot of people just don't realize that what happens in our freshwater environments does have a huge impact on our saltwater environments. We see that here in Florida, and I'll touch on it more towards the end of the slideshow, but we see that with our algal blooms, especially during the summertime, and I'll touch more on that as we keep going. So the water cycle, so we now have some cool animations. So we see that droplet as it heats up, it begins to evaporate, and then it condenses into that cloud. It rains, and as it rains, the sun comes back out, transpiration, which we'll talk about in a moment. And then we run off, boom, and then he's back to hanging out on his chair. So it's just a good example of what happens to a water droplet in the water cycle. So we're gonna start with evaporation. So evaporation is energy from the sun, heats the water on the Earth's surface, and it causes it to turn into water vapor and go up into the atmosphere. So the best example is if you have a puddle, especially here in Florida, because of the rainy season that's coming up, we will see sun and clouds, and it could be pouring one minute, it could be beautiful and sunny the next minute. So we see those puddles disappear very quickly, and that animation on the bottom left shows that. So as the sun heats up those water molecules, they begin to evaporate, and then they start going up into the sky. So when all of those water molecules start hanging up in the sky, they begin to cool down. It actually kind of squishes them together and condenses them, and they form this cloud. The best example we have is when we are out on a hot sunny day, if we have a ice drink and those the water droplets that start collecting on the outside of our cups, that is condensation happening. So once the clouds are so heavy, there's so many water droplets hanging out in there because of the water vapor cooling, it begins to rain. So, or precipitate, we'll say. So precipitation is what happens when there's so much in those clouds, it gets so heavy, the water begins to fall back down to Earth. And there are a couple different types of precipitation: rain, snow, sleet, or hail. I'm sure in Vienna, you're familiar with more of the colder ones. So the snow, sleet, and hail. In Florida, we don't get too much snow unless you're pretty far north in Florida. So luckily where we are near Fort Lauderdale, at least luckily for me, we don't get any snow. But if you're a little bit further north of us, it is possible. It's strange, but it is possible. And precipitation is what connects the ocean to the land to the atmosphere. Because the rain is starting up in the atmosphere, it falls down onto our land, and then because of runoff, it eventually makes its way back to the water cycle, or back to the ocean. So this is really important for how water moves through that water cycle, because it gets it back to the Earth. So good example, that bottom left corner of all the rain dropping hitting the ground, which we should be having shortly, if not definitely tomorrow, we'll be getting a lot of rain, it says. So this next one is called collection, but it's also called runoff and groundwater. It's kind of, it encompasses a few things. So once that water hits the ground, a couple things happen to it. So it could run off. And it could kind of go a few places. So groundwater is when water hits the ground and soaks back down to the earth. And then that water can even go further down. So here in Florida, we have aquifers, which are underground caves. And that's where we get a lot of our fresh water from here in Florida, or drinking water. So as that water seeps into the ground, it percolates. So kind of exactly how coffee is made. So you put coffee in, it heats it up, and as that water slowly drips off the grounds, as it seeps through or percolates through and drips down into your coffee pot, that's how we get the best liquid ever, I think. So percolation is the process of water seeping through the ground, and that eventually ends up in our aquifer here in Florida, and I'll talk about that in a moment. So runoff is any water that didn't get absorbed by the soil and then just keeps running downhill. We don't have many hills here, but there is a little bit of an elevation difference. So it will run downhill, and eventually it gets to a river. Now, all rivers lead to the ocean somehow, some way. And since those rain droplets, since they are running off that surface, they pick up whatever's in their path. So it could be something like nutrients from farms. As it rains on farms, it picks up that phosphorus and nitrogen, runs off to our rivers. It could be pollution. So something like a plastic bottle, a plastic straw, a trash bag. I actually saw a balloon. It rained Sunday, and there was a balloon on the street, and the rain just kind of took it, or the runoff took it, and it just kept going. It could also take sediment as well. So this picture right here shows just how, as that water runs off, it creates erosion. Not always a good thing, especially right there. So now, oh, I put Captain in this, nice. So now we're gonna go to another kind of, it's a part of the water cycle, but it's not one of the major three ones. And we had talked about how we are constantly losing water. So humans and animals and plants, we're all part of the water cycle, whether we're aware of it or not. Even as I'm sitting here talking to you right now, I'm a part of the water cycle. And the thing that I'm doing right now, and all humans are doing, is that we are constantly breathing. So every time you exhale, you let out little tiny droplets of water vapor. The best example of knowing if you're part of the water cycle, especially in Vienna where it's cold, when you breathe and you can see your breath. So because the air is so cold and the water molecules coming out of your mouth are warm, they freeze right in front of you. Or if you're in sunny Florida and it doesn't get that cold here, if we fog up a mirror, we can see, or if you fog up your parents' car and then draw a smiley face in the window and then they get mad at you. So that is a great example of respiration. Like I said, we also sweat and we also go to the bathroom, but even when I'm sleeping, I'm a part of the water cycle, which I think is amazing. Now, transpiration is when plants lose water through their leaves. So the best example of that is when we go out in the morning and if there's dew on the grass. So as the temperature changes at night, that actually encourages the plants to release water. So if you've ever walked on the grass early morning and your feet get all wet, that's just the plants releasing water. And then Captain, our resident green sea turtle here at the MEEC, she's always, well, not always, because she's very good at holding her breath, but she's part of the water cycle, and you can see right there, she's exhaling, so she's part of that respiration process. And then that just shows air going into the lungs, taking a big deep breath in, and then exhaling. So I told you about the aquifer before. It's that underground cave. Here in Florida, that we're just really unique because that's where we get all of our fresh water from, our drinking source. So it's a layer of rock and caves underneath Florida. It's made up of limestone. So limestone, I think, is one of the coolest rocks on the planet. It is actually made up of dead fossils, and so dead animals and dead coral. So millions of years ago, before Florida ever existed, this was actually the middle of the ocean. And as those creatures in the coral died, they started to fall to the bottom and they started to stack on top of each other. And now that pressure from the ocean, just because it's on the bottom, would actually compress and push those animals and dead corals together, and more would stack and it would squish and it would stack and it would squish, and eventually formed our layer of limestone. So if you were to find a piece of limestone, you could actually find a fossil in it. And I'm going to go grab one because I know we have one in here. So this is actually a piece of limestone from Florida. And you can see we actually have some shells in here, so a lot of bivalves. So that's a lot of what we'll find in here. So our clams, scallops, mussels, and oysters, those are going to be our bivalves. We'll also find gastropod shells, which are snails, and whelks and conchs, things like that. Sometimes you will find fish bones. I had one of the places I worked at had a really great piece of limestone that actually had a dugong skeleton or piece of vertebrae in it, which was really cool. And then like a mini small piece of brain coral. So they're just great pieces of rock to look at because you just see so much stuff in it. And one of the follow-up questions I like to ask, so based on your description of limestone, that it's made up of dead animals, so dead coral and fossils, what type of rock is limestone? Is it metamorphic? Is it igneous? Or is it sedimentary? I'm gonna guess you meant sedimentary with the SEM. I'm not quite sure, but I'm guessing that's what you meant. But yes, it is sedimentary. So sedimentary is when rock is made up of different sediment. So that's exactly what our limestone is. And here in Florida, we actually have 4 layers underneath the ground. So if we were to go outside and start digging, we would actually go through 4 layers. The first one would be soil, then it would be sand, then it would be clay, and then eventually we would hit that limestone. How deep down the limestone is kind of depends on where you are in Florida. And what's really cool about those 4 layers underneath us is that they act as natural filters. So as the water slowly percolates down through the ground, those 4 layers will take out the toxins, anything that's not supposed to be in there, and it actually clean the water. So by the time that water ends up in the aquifer, it's pretty clean and it's good to go for us to drink. There is one particular layer that is a better filter than others. Do you want to take a guess of if it's soil, sand, clay, or limestone? Which one do you think is the best filter for us? Ooh, that's a good guess, but what if I told you clay is actually the best filter? The reason why I know this is the last place I worked at, we actually had 4 bottles. And this is an experiment that anyone could do at home if you have access to soil, sand, clay, and limestone. But we filled up a little bit of the bottle with sand, 1 with soil, 1 with clay, and 1 with limestone rocks, small limestone rocks broken up. We filled the rest of it up with water. And what you do is you have hopefully 2 people, because if you have 4 hands, we got some issues. But you take 2 bottles, 1 in each hand, and another person takes 1 in each hand. You shake them up, shake them up, shake them up, shake them up, and then you put them down, and then you time it. So you timed it to see how long it takes for the sediment to separate from the water. So fairly quickly, the limestone separates right back because it's mostly rock at that point. So the water and the limestone separate really quickly. So we know that's not the best filter. Then based on the soil, sand, and clay, soil separates pretty quickly after that. And then sand will separate a little bit slower than our soil, and clay actually takes about 15 minutes. If you had that small bottle, shook it up, had clay and had water in it, it takes about 15 minutes for that to completely separate back into the clay layer and the water layer. So the slower it takes to separate, the better of a filter it is. So soil's okay, sand's a little bit better, clay is the best filter, so that by the time it gets to the limestone's like, bring it in. I don't have to work really hard because the clay has filtered a lot of it for it. So the clay is the best filter. And here in Florida, we have the Floridan aquifer. So if you look at the top left photo, the lighter gray shows you the Floridan aquifer, and it extends into Georgia, into parts of South Carolina. It goes over to Alabama, and it actually continues a little bit into Mississippi. This map didn't include that, but it's pretty large. It's one of the most productive aquifers on Earth. And it's, like I said, the main freshwater drinking source for us. So as it seeps down into that aquifer, so underneath Florida, that limestone, there's a whole bunch of underground caves, and they're all connected. There's actually a video, it was a movie, I wanna say it was made in the either late 90s or early 2000, I think it was late 90s, and I forget the name of it. But there were 2 divers who actually went down and dove the entire length of the Floridan aquifer. They had GPS trackers on them, more or less, and they had people at the surface on land tracking them. So as they went through the caves, you have people walking through parking lots, walking through restaurants, walking in backyards, walking on streets, following them just to show you that it is all connected. So once water gets into the aquifer, it won't stay there forever. It might stay there for a while, but it won't stay there forever. There are actually 2 ways that water can leave. The first one is the natural way, which are springs. So springs are the natural way that water leaves the aquifer, and it's basically just a big hole in the aquifer, in the rock. Here in Florida, we have a whole bunch of springs that people love to swim in. We go there usually in the summertime. But one really cool thing about our springs is that they stay the same temperature year round. They stay anywhere between 68 and 70 degrees. So depending on the time of year that you go, the temperature will actually feel different. So most people in Florida go to springs during the summer months. It probably feels really cold when you go there because the outside air is going to be like 89 to, we'll go 85, will be nice, 85 to like low 90s. So if you're in air that's 85 degrees and you get into water that's 72 degrees, it's going to feel chilly. It's going to feel refreshing. It's going to feel chilly. You might need a wetsuit. Now, if we were to go on a cold day, because it does get cold here sometimes. So if we went out when it was, let's say it was like 60 degrees in the morning, we go out to a spring. So if we're in the 60-degree air and then we get in that 72-degree spring, the spring will actually feel really nice. So my personal favorite time to visit those springs are the wintertime, or excuse me, is the wintertime, because the water feels better, less people around because most people go in the summertime, and manatees. So we have these really cool marine mammals, manatees, that will actually go inland during the winter months. So most marine mammals have a thick layer of blubber to help them survive in the cold water environment. Manatees do not. So one way that they've evolved, or they've adapted, they actually go inland because those springs and our rivers here in Florida stay around 72 degrees. And we also have some power plants along our rivers that pump out heat as a byproduct. And we actually have some like natural preserve areas for manatees to hang out where power plants are. Manatee Lagoon up near us in, I believe it's in West Palm. They have a really great spot over on the west coast of Florida. There's Manatee Park in Fort Myers, where it's just power plants that are releasing heat as a byproduct, and then the manatees just kind of congregate for the winter months because they have fresh water to drink, it's warm, and then they have a lot of seagrass and algae to eat. And then once it starts warming up again, so April and May, they actually migrate back out to the oceans, and then they'll hang out in the oceans until about November, December, and then they'll start moving back in. If you're familiar with Crystal River, which is over north of Tampa on the west coast of Florida, and Crystal River, there is a whole park dedicated to snorkeling and diving with these manatees because they love to hang out there, especially during the winter months. They do rope it off. So because they are a marine mammal, they are protected under the Marine Mammal Species Act. You're not allowed to hunt, harass, kill, or bother or touch a manatee. So they actually have an area where you can snorkel with them, but then they rope off an area that if the manatee goes in there, you can't follow them because you're not allowed to bother them. But it's really cool if you want to get an up close and personal look at those guys because they're very interesting animals. We have over 700 springs here in Florida, and they range in the magnitude. So magnitude is just, it just measures their strength or how much water is being discharged through it. So magnitude 1 is going to be the largest, magnitude 5 is going to be the smallest. And we have 33 magnitude 1 springs. Most of them are state parks where you can go visit and play in the water. There, a lot of times there's nature trails you can go around. Some of them will have boating tours you can go on and just kind of view the river, which is really cool because there's a whole bunch of animals there. So springs are the natural way that water leaves the aquifer. And we also have wells, which are the man-made way that water leaves the aquifer. So wells, basically we drill a hole all the way down to the limestone layer, stick a big pipe in it, and then that pipe sucks it up like a giant straw and brings it to anywhere that you use well water. So a lot of people here in Florida do have well water. I don't mind the taste of it. It definitely tastes a little bit different than if I were to just turn on the faucet at like my mom's house up in New York, but it's not that bad. It's not that bad. So a watershed, we got a couple more minutes, so I'm gonna kind of go through this a little quickly. So a watershed, a general definition for it is any piece of land that rainwater can run off of. So where I am right now at the Marine Environmental Education Center, I am technically on a watershed, right? Because this house is on land and it rains on top of this house, right? So check, that's a watershed. So all of Fort Lauderdale, that is a watershed because it is land and it rains on Fort Lauderdale. All of Florida, watershed. All of the US, watershed. Canada, yes. Mexico, yes. Sweden, yes. New Zealand, yes. Australia, yes. Outer space, no. Outer space is not a watershed, right? Because there's no land, it doesn't rain out there. So as long as you are on land and it rains on that land, you know you are on a watershed. So wetlands and recharge areas really do help our watersheds because those plants, again, they act as natural filters, just like our soil layers, but our plants are actually better at it. So as those trees, shrubs, grass, as those roots suck up the water, they actually filter out the toxins for us and allow the rest of that clean water to go through the plant and then eventually gets released by transpiration back into the water cycle. A lot of things factor that or influence the health of a watershed, like pollution, whether that's plastic pollution, any sort of trash that's lying around, fertilizers and pesticides, and I'll talk about that in a moment. Gas and oil, especially in our parking lots, so Publix parking lots, as it rains and hits those gas and oil spills, It'll pick up those gas and oil molecules and then run off into our watershed, animal waste, and then even land development for humans. So fresh water in the ocean. So how is this all connected? So I already said that all rivers lead to the ocean. And one of the biggest issues we have here in Florida is as it rains, especially in the summer season, in the middle of the state, we have a bunch of agriculture. So we have a lot of sugar farms. We have a lot of orange, I was like, what is that word? A lot of orange farms. We grow a lot of cattle. So there is, especially with our oranges and our sugar, we have, our farmers put, pesticides and fertilizers, things like that, just so that they can protect their crops. But as it rains, rain picks up those particles, and then it runs off into our rivers. And then our rivers, like I said, they lead to our ocean. So one of the biggest issues we have are harmful algal blooms, especially in the summertime. So red tide, which happens unfortunately pretty regularly here, at least once a year. Sometimes it'll actually run into the whole year. But it's actually caused by one of our algae. It's called Karenia brevis. It's a red algae. And it usually happens in the summer because it is fueled by that nutrient runoff. Since it is rainier in the summertime, there's gonna be more runoff and the heat. So heat really helps algae grow as well. So that Karenia brevis actually produces a toxin that has harmful effects on us. So humans, if there is a lot of red tide happening, it actually causes respiratory issues for us if we have trouble breathing. Back in 2018 on the West Coast, and even on the East Coast of Florida as well, but the West Coast especially, it was a huge algal bloom. And I actually had friends and family who are still over there, and they had a very hard time going outside, especially older people. It affects them more, and kids. One of my aunts was having a hard time breathing. It also can affect our fish. So if you look at the top left photo, there's a lot of dead fish that wash up, dolphins as well, turtles, manatees, birds, everything. It can start, so biomagnification or bioaccumulation, it starts small, so in our plankton, and then as it moves up the food web, it causes a bigger issue. So a lot of our manatees, a lot of our dolphins died off because they couldn't breathe. So water conservation, how can you help? Because we always got to spin it in a positive way. It is a renewable resource, like I told you, through the water cycle. However, if we don't treat it, if we don't take care of it, if we're not mindful of our usage, it can cause some issues. We could run out of it. Again, we have 1% of that, or 97% of all water on Earth is salt. 3% of that is fresh. Only 1% of that 3% is accessible for human usage, along with our animals on Earth and our plants. Again, 7.8 billion people on this planet, and we use water every day. So little changes to our daily life can have a huge impact on water. So when you are brushing your teeth, you don't need to leave the sink on. Definitely turn it off, because if you're scrubbing, the water doesn't need to run. When you're washing your hands, as you're scrubbing, especially for that 20 seconds now, as always, actually, you don't need that water to run. You can kind of hook it with your elbow, wash, and then grab a towel. Make sure you turn the faucet off so you don't dirty your hands again. Showering. So if you were to take an 8 to 10 minute shower, that would use over 100 gallons of water. Whereas if you took a bath, it would only use about 25 gallons of water. So because when you take that bath, you plug up the bathtub, you fill up the bath, and then once it's filled, you turn it off because you don't want to flood your bathroom. And then you can hang out in the bathtub for as long as you want. I am a tall human, although it doesn't look like it sitting down. I don't fit in most bathtubs. So one of the things that I do to help with water conservation when I'm showering, I actually will go in with my iPod and I give myself 2 songs. So that's about 6 minutes. And I try to get done before the 2 songs are up. If I do, I usually eat a treat like a cookie or a peanut butter cup because I did a great job and I deserve positive reinforcement. If I'm feeling really rambunctious, I try to get done within that first song. So about 3.5 minutes. One option you could do, you could turn the water on and off as you need in the shower. So turn it on, get your hair wet, turn it off, shampoo, turn it on, rinse the shampoo out, turn it off, soap up your body, turn it on, rinse off the soap. Even saying that, I got confused. I've tried it multiple times, and every time I do that, I walk out of the shower with shampoo in my hair, soap on my body, or face wash on my face. So that one's not realistic for me, but if you can do it, more power to it. That's why I do the timer thing, just so that I'm holding myself accountable for being a better human. Leaky pipes, we definitely want to fix those because although it might only be a slow drop, that adds up over time. Washing dishes, one thing, a dishwasher versus washing them in the sink, if you were to run a full dishwasher, that would actually save more water than washing dishes by hand in the sink. However, I do not have a dishwasher. So one thing that I do, I actually plug up my sink. I fill it up like a mini bathtub. I do the scrubs. I let it drain, and then I fill it back up to give it a quick rinse. Again, just so my sink is not on the whole time. Another thing, I have a watering can right there. When is a good time to water your plants? And that's actually in the morning or at nighttime. You don't want to water it in the middle of the day, especially here in Florida, because basically if you were to turn on your sprinkler at 12 p.m., the sun is so strong that water's going to evaporate almost immediately. So morning or nighttime is a good time to water your plants just because it's a little cooler out and that water won't evaporate as quickly. All right, so I kind of went through that last part a little bit fast, but just because I was afraid we were going to get kicked off. But if you have any questions, go ahead and shoot it in the chat. I can answer them, and if not, that's okay as well. This is me and Dennis hanging out today. Have fun enjoying. Did you? Yes, we did record this. So Taylor, our other educator, and who's really taken the reins on all the technology things, she will. Once we're done recording, she's going to just edit it a little bit because in the beginning it was just me sitting here by myself for 8 minutes and it was kind of weird. So she's going to edit it and then she will post it to our YouTube channel. So if you don't know our YouTube channel, just look up Seek the MEEC, and all the other programs that we have recorded so far will be up there. We will also post it to our Facebook page. So that is facebook.com/seekthemeek, or if you search the Marine Environmental Education Center. Next week at 1 p.m., next Thursday, we are doing our cephalopod program. So we'll learn all about those aliens of the sea, and you guys will also be able to see a virtual dissection of one. Again, that is at 1 o'clock. And then May 28th, so 2 Thursdays from now, that will be our, oh, I know, I'm sorry, I speak very fast. I get too excited. But we'll slow it down. I speak fast. You do. Sorry, I just get so excited about science. I'll work on that. Next, so on May 28th, we will be doing a coral conservation program. So look out for that as well. And then for the month of June, I think we are going to start having guest speakers join us. So because of all of our backgrounds, because we're all involved in science, and as we've progressed in our careers, we've met a lot of people. We're going to start bringing in some experts. So some shark people, some turtle people, some manta ray people. So keep your eye out for our Facebook page, and our Facebook page actually is where we'll post it. I was going to say YouTube.
But we also send out email blasts.
Yes.
There's a place to sign up on our Facebook to be part of the email blast.
Fantastic. So if you want to sign up on our Facebook page with your email, so you'll be included in our email blast as we have more programs, and as we are getting more advanced with our virtual programming, feel free to either or even message us at the MEEC on Facebook and send us your email. We can get you in there some way. So yeah, thanks for hanging out today. I'm working on my speed. I'm from the Northeast, so it's just fast and furious. And then if I get excited, it's even faster. And then you put science in there, game over. And I had coffee. But I'm working on it, and Taylor does a really great job of slowing me down when she edits and then posts to YouTube. Makes her life harder when I talk fast, but I just get too excited. But thank you for hanging out today. I hope you stay safe. I hope you're hanging in there. And we will hopefully see you either next Thursday or this Saturday. We do a captain feeding on our Facebook page. So Captain's our resident green sea turtle. So feel free to check us out then. Awesome. Thank you, Dennis. You have a great day, and we will see you soon.